45 minutes. We're going to do organic chemistry, organische chemie, and then we're going to go over to Newton's laws. Okay, because you do write on that in this test series. Goed, so ons is by alkohole. We stopped yesterday, ons het gesê, they have that OH group, die OH groep, wat ons die hydroxyl groep noem, 'n hydroxyl group. Ons het gesê, as gevolg van daai hydroxyl, due to that hydroxyl group, we have hydrogen bonding intermolecular forces. English learners, I think I did not say with you, that because there's one OH, een OH, we could say there's one site for hydrogen bonding. One site for hydrogen bonding. So I want you to write there, one site, een plek. You can also say one point for hydrogen bonding, but they prefer the word site. Okay, yeah. Very, very important concept to understand. That is not a hydrogen bond. Daar is nie waterstofbinding nie. Daar is 'n kovalente binding, 'n covalent bond. The hydrogen bond is between one molecule and another molecule. There's an intermolecular force. Daar is 'n waterstofbinding. Even though it's not a bond at all, it just looks like a bond because they're so close together. Okay. Good. Then the uses, where do we use alcohols or alkanols? Ons gebruik hulle as hulle brand. They burn in oxygen to form carbon dioxide and water. And then we use them fuels for cars. What's vuurpyl in Engels? Ek record. Vuurpyle, missiles, rockets, stowwe, alcoholiese dranke, glycerol, en. Alright, so what are we going to do there? Is we're going to look at those four compounds, en ons gaan net hulle struktuurformule, the structural formula we are going to write. Okay, methanol. Meth beteken 1 carbon. If you see an ol, it means it's part of the alkanols or alcohols, alkohole, alkanole. So dit beteken om met 'n OH wees. Right. Jy kan dit so gaan skryf. Okay, so in a straight line or at an angle like this. As jy sou wou. It's all the same, dit maak glad nie saak nie hoe dit werklik lyk. What it actually looks like is at a weird angle like that because there's two lone pairs. Okay, maar as jy dit nie so teken nie, glad nie die einde van die wêreld nie. Then we need to fill in the rest of our hydrogens. There is 1, 2, 3 other hydrogens. Okay, methanol. Very deadly. Okay, do not consume. Volgende ene is ethanol. Eth beteken 2. So ons het 1, 2. Okay, and then they did not say ethan 1-ol or ethan 2-ol. Gaan dit saak maak? No, because ethan 1-ol would be here and ethan 2-ol there, but this can be ethan 1-ol. Okay, so it doesn't matter. Morning. Welcome. Alright, so dit maak nie saak nie, and it also doesn't matter where you put the OH. So jy kan hom nou dit aan hierdie kant gaan sit as jy sou wou. Because this is a symmetrical molecule. Volgende, okay, Afrikaans kies hier 'n tikfout wat ek nie verander het nie. Dit moet butan met 1 A wees. Nie butan nie. Butan. Butan 1-ol and butan 2-ol. Okay, but means 4. So we have 1, 2, 3, 4. Okay, butan 1-ol tells you on the first carbon there's an alcohol. Nou net omdat die spasie limited is, because the space is limited, I am going to just put in little streepies. Okay, and butan 2-ol, again, but means 4. And now on the second carbon, there's an OH. Okay. Then two things I want to look at here. The first one is, let's try to get a general formula. Kom ons probeer 'n algemene formule te kry hiervoor. Okay? If you think about the general formula for an halo alkane, what was it? Môre, it was CnH2n plus 1x. Nee? Ja? Okay. Kom ons kyk gou hierso. Sê nou maar dit is hierdie ene. Let's look at that one. Then we have 1, 2, 3, 4. Then how many hydrogens do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. And 1 oxygen. Jy met my? Okay, kom ons kyk gou hierdie ene. 1, 2 carbons. 1 oxygen. And 1, 2, 3, 4, 5, 6. Same here. So, what general formula can we derive from there? Wat 'n algemene formule kan ons van daar af aflei? CnH2n plus okay. Want as jy hierna kyk, if you look at this, we're going to write it now on that other page as well. As jy hierna kyk, if you just delete that oxygen en die waterstof kom in daai plekkie, dan sit 'n alkaan. Then it's an alkane. If you delete that oxygen, put that hydrogen in there, it's an alkane. So daai gedeelte, oepsie, askies, is presies soos 'n alkaan se, né? And then you just add the oxygen. So on page 2, bladsy 2, alkohole. Is dit CnH2n plus 2O. Okidokie. Goed. Dan die volgende ding wat ek wil uitwys, the next thing I want to show, is as jy kyk na butan 1-ol en butan 2-ol, then their boiling points differ a lot. Hulle kookpunte verskil baie. Okay? Maar dit is presies dieselfde ding. It's exactly the same molecular formula. Dit is al twee butanol. Hoekom verskil hulle kookpunt so baie? Why do the boiling points differ so much? Ja. Okay, so dit het alles te doen met waar hierdie ene geplaas is. It has to do with where this one is placed, that OH. Okay? Want, en my spasie hier is nou very, very, very limited. So ek gaan dit vinnig op die bord verduidelik en dan gaan ek dit hierso neerskryf. If we look at butan 1-ol, then the rest of this thing is, this side is London forces, blah, blah, blah. But here we have a very open, a baie oop, polare gedeelte. Môre, a very open, this one, a very open polar part. Okay? Wat beteken dit is soos 'n sterk magneet. It's a very, very strong magnet this side. It can attract something. Maar as jy kyk na butan 2-ol, okay, dan, en nou put in the hydrogens here, dan kan jy sien this OH part is shielded. Hy is afgeskerm deur hierdie waterstof. Want onthou, these are actually molecules with orbitals around them. Okay, so dis nie streepietjies in die nie. It's orbitals going and overlapping muscle. So hierdie O, this O, is shielded. Hy is afgeskerm deur die waterstoffe. So even though yes, this is still very much negative, hy is asof hy something that's blocking its attraction force for another molecule. So this one is shielded, hy's afgeskerm. So beteken sy intermolekulêre kragte is nie so sterk nie, beteken minder energie word nodig om sy intermolekulêre kragte te oorkom. Wat beteken sy kookpunt is laer. Okay, so I want to write here, we're going to look at the boiling point, I want to compare to that, and I want to say OH is shielded. So, that's less polar, more, that's weaker intermolecular forces, thus less energy needed, thus lower boiling point. Okay, so in Afrikaans sê die OH is afgeskerm. Okay. Okay, so jy sê die OH is afgeskerm. Dis minder polêr. OH is afgeskerm. Dis minder polêr. Dit wil sê swakker intermolekulêre kragte. Dit wil sê minder energie word benodig. Dis laer kookpunt, né? Yes. Less energy needed. E needed. Okay. Good. Then just I want to say for interest sake, for interessantheid, alkanols can be oxidized to aldehydes and carboxylic acids. Hulle kan geoksideer word na aldehyde en carboxylsure by very strong oxidizing agents, oksideermiddels. Okay, en dan hierdie oksideermiddels moet jy al eintlik ken. You need to know these oxidizing agents by now. Hulle name, hulle kleure. We worked with them last year, especially the first one. Kan iemand my hulle naam gee, die eerste ene? This one's name? I can tell you it's purple. Pers. A purple crystal. Prachtig. Kalium permanganaat, potassium permanganate. Potassium permanganate, purple crystal. En hierdie ene, he is orange. Oranje. Kalium dichromate. Potassium dichromate. Potassium dichromate. Okay, goed, so wat ons hierso dan nou het, is, daar is jou ethanol, how do I know it's ethanol? Because it has 2 carbons with an ol. Then, if it is oxidized, as dit geoxideer word, dan in die eerste stap word die H's verwyder. So, those two fall away and they form a double bond there and you get an aldehyde, ethanol, an aldehyde. And then it is oxidized even further, so now they add oxygen and I word a carboxyl C. It becomes a carboxylic acid. Okay, now you guys don't know this yet because you don't consume alcohol yet, né? Maar, so gisteraand, ek het mense wat by my kuier vir die naweek. En ons maak 'n bottel wyn op. I'm from the Cape Town, I come from a wine farm, so ek hou van wyn. So you open a bottle of wine, maar jy drink hom nie dadelik nie. Okay? You throw him into like a glass thing, a decanter, noem jy hom. Okay, why do you do that? So that the alcohol, they say it breathes. Wat ons bedoel, hy kry 'n suurstof, it oxidizes, then some of the alcohol, not all of it, some of it changes to an ethanol. En dit proe en ruik lekker, so dit maak net die alcohol lekkerder smaak. Okay, now we had a nice evening, went to bed quite late, left the bottle open, vanoggend, wil jy 'n slukkie vat en dan sê jy so, ja, daai nou is hy nie lekker nie. What happened? It oxidized too much and the alcohol now became an acid, it became vinegar, ethanoic acid. Nou proe jy my nie meer lekker nie. Okay, so this is die tipe proses wat dit volg. So, it happens with most alcohols, but not all of them, hierdie proses. So meeste alcohole, if you leave it open for like half an hour, the flavor is where it should be. For future reference, don't try it tonight. Don't try it at home. Okay, goed, dan nog 'n gebruik vir 'n alcohol is glycerol, alcohol, glycerol. It's a byproduct, mean it's like a throwaway product when they produce soap. Then you get glycerol, and we use this glycerol in Vaseline. Okay, you can see there the glycerol has how many OHs? Hydroxyls? 3. What do we call 3 of the same thing? 3 van dieselfde ding? 3. So hierdie is 'n triol. Triol. Okay? And what will the name be? Ons het mos nou name baie geoefen. What do we call 3 carbons? Prop. Welcome. Prop. Then between the carbons there's single bond, so it's propan. Alright, and then where do we find the alcohols? On the first, second, and third. Okay, so it's propan 1,2,3 triol. Propan 1,2,3 triol. En okay, so hierdie ol deel is deel van sy funksionele groep. En funksionele groepe kom altyd aan die einde. So wat ons gesê het alkeen. So funksionele groepe kom aan die heel einde. So hierdie word nie gesien as 'n syketting nie, word gesien as 'n funksionele groep. Sykettings is net brome. Ja. There was something else that I wanted to say here. Ma'am, but there's 3, so do you need to say 1,2,3? Jy moet, want it could have also been like this. Okay, so jou triol kon ook almal op dieselfde koolstof gesit het. En dan sit gewees het 1,1,1,1 triol. 1,1,1,1. Ja, nee, too much. Anyway. Right, and then the last one, ethanol, that we use in alcohol, word gevind in alkoholiese drankies en word gevorm wanneer suiker fermenteer. When you have sugar and it ferments, then so your glucose, your sugar reacts and it forms ethanol and carbon dioxide wat jou gasbotteltjies maak. Okay, reg, dan wil ek gaan na die volgende kyk. Ons kry iets soos 'n primêre, sekondêre en tersiêre alkohol. Okay, now if you quickly peek to page 2, as jy nou bladsy 2 kyk, then you can see at the alcohol functional group, we have this 1, 2, and 3. Okay, this refers to the primary, secondary, tertiary. Dis is die eerste graads, nie? In this chapter we say primary, secondary, and tertiary. So hier het ons dan ons primêre, sekondêre en tersiêre alkohole. Okay. Now this is a definition or a concept that they ask in every exam. Ek dink die afgelope 3 jaar het hulle dit in elke eksamen gevra. Okay, so you need to understand this concept, and these are almost like definitions that you need to study word for word. Hulle sê, what is a primary alcohol? Is an alcohol in which the carbon atom bonded to the OH is bonded to only one other carbon. So die koolstofatoom gebind aan die OH groep is gebind aan slegs een ander koolstof. Okay, so let's look at that thing there on the right hand side. Wag, voordat ons kyk op wat se graad hy is, wat gaan sy naam wees? How many carbons do you see? 3. So 3 is prop. Between the carbons is single bonds, is propan. And then you see you have the functional group, the alcohols, die functionele groepe alcohol. En hy gaan sit op die eerste koolstof. So dis propan 1-ol. Propan 1-ol, propan 1-ol. Same spelling in English and Afrikaans. Okay, nou, wat is 'n primêre alcohol? It says the carbon bonded to the OH. Daar's die OH, daai koolstof. So the carbon bonded to the OH. So die koolstof wat aan hom gebind is, that carbon is only bonded to only one other carbon. So hy is gebind aan net een ander koolstof. Is bonded to only one other carbon. So dit word gesien as 'n primêre alcohol. Primêre, this carbon is only bonded to one other carbon. Secondary alcohol, secondary alcohol. The alcohol in which the carbon atom bonded to the OH is bonded to two other carbons. Okay, so as jy kyk, die koolstof, this carbon, attached to the OH. Okay, so the carbon attached to the OH is attached to two carbons. Secondary alcohol. Okay, en dan die tersiêre alcohol is waarin die koolstofatoom gebind aan die OH groep is bonded to 3 other carbons. Okay, nou met daai skets is daar 'n probleem. There's a problem with that sketch. What is that? Chamatay? Nee. Marie? Yes, if you look at this carbon, hoeveel bindings kan 'n koolstof maak? 4. 1, 2, 3, 4. So that hydrogen should not be there. Okay, so it says that this carbon bonded to the OH group is bonded to 1, 2, 3 carbons. 1, 2, 3 koolstowwe. Okay, please be careful. Don't say the OH is bonded to 3 carbons. Hierdie hydroksielgroep is nie aan 3 gebind, hy is net aan 1 gebind. The carbon bonded to the OH is bonded to 3. Not the OH is bonded to 3. Back. Dan, ek het nou vergeet om die name te oefen. What will the name be of this compound? It's 4 carbons, so it's bute. Butan 2-ol. Butan 2-ol. Okay. And then the last one, what will his name be? If you put up your hand, I'll give you a lollipop if you are right. Yes, Tawana. Not 100% correct, sorry. Ja? Nee, ook nie? Ja? Wat? Ek kan nie hoor nie. Maar ek dink nie is reg nie. Ja? Nee, maar nou by Kayla. Nee, maar ja, jy het al die goed reg gesê, maar dit is verkeerd. Okay, want jou volgorde is verkeerd. Maar jy sal 'n lollipop kry. Okay, so let's quickly, because why am I practicing these names? Jy moet dit nou al kan doen. Okay, So, the parent chain, die hoofketting, is natuurlik. So, you're writing this down, eh? Is propan, pro because there's 3, and because there's single bonds. And then on the 1, 2, 3, the second carbon there's a ol. So propan 2 ol. So that is the surname, jou van, die hoofketting. That is the main chain. Okay? Because that is not seen as a side chain. Dis nie 'n syketting nie. Dit word gesien as die funksionele groep, functional group. Okay, so that and that is sorted. Now we're left over with that. That is a methyl, and that methyl is on the second carbon. There's a meth, because there's 1 carbon. Al, because it's a side chain. Net 'n vraag, kan daai methyl, can that methyl be on the first carbon? Nee, want as op die eerste ketting, op die eerste koolstof is, okay, if it's on the first carbon, then it will be butanol. So, jy hoef nie te sê 2 methyl propan 2 ol nie. You can just say methyl propan 2 ol. Okay. Goed. Dan sommer net vir interessantheid. So, I really have friends visiting here. And we all studied chemistry. Okay? So this morning we had a chat about chemistry. En hulle praat oor piesangs en jy weet soos alles die chemicals daarin en hulle sê hulle probeer slim klink en hulle sê you know the hormone that makes fruit ripe is you only find it in bananas and avos and a little bit of mangoes, and it is called ethylene. En ek is soos, wag, wait a minute. My graad 12's kan hierdie uitfigure. Hoeveel koolstof? 2. Lean of een dubbelbinding. And I was like, what's the ethylene? What does it beteken? 'n Syketting, maar eth can't have a side chain because it was net 2 en ons Google het en toe het hulle dit verkeerd toe sit ethene. So nou weet jy ethene, 2 koolstofatomme is die hormoon wat vrugte ryp maak. So jy nou weet jy 'n bietjie meer. En jy weet wat my in die oggend aangaan. Okay.
As ons die propan in die einde moet sit, is dit dan propan. Maar as dan daar sê jy propan.
Ja, so sê net maar dit is 'n alkaan net. So daar's geen sulke dinge nie. Né? So is net dan sit propaan. Maar sê net maar daar's 'n ander funksionele groep, so 'n OH, dan word dit kort, dan sit propanol, propanol. Okay. English, you don't have that problem, yours is always 1A. Ek was seker daar was nog iets wat ek wou sê hierso. Ja. Laaste ding wat ek wou sê hierso is if this substance oxidize, as hierdie stof nou oksideer. Oxideer, the first step means an H falls away. 2 H's falls away. That's the first step. Then this becomes a double bond OH. To which homologous series, homologe reeks gaan dit behoort? So at the end of the chain we have a double bond OH. Aldehyde, an aldehyde. If this one oxidizes, as hy oxideer, 2 H's falls away and it forms a double bond O. Watter homologe reeks? Sê? A ketone, a ketone. And this one? Oh no, this one. Laat ek net gedink. This one cannot oxidize because there's no 2 H's that can fall away. So as hierdie oxideer, so if you have the OH at the end, if it is a primary alcohol and it oxidizes, it will form an aldehyde. If this oxidizes. If the OH is in the middle of the chain, as hy in die middel van die ketting is, en hy oxideer, dan word dit 'n ketoon. Okay. Yes, Menai. Ja, ja. So hierdie een, die C gee waterstof op en die O gee waterstof op, dan kan hulle met mekaar bind. Okay. Then here at the end, weer eens het ek fout. Propan 1-ol, propan 2-ol. Just by Afrikaans is al fout, nie die Engels nie. Okay. I quickly want to draw it first. Prop means how many carbons? 3. 1, 2, 3. 1, 2, 3. Okay. Then propan 1-ol, sê vir jou op die eerste ene is daar 'n OH. On the first carbon there's an OH. Propan 2-ol tells you on the second carbon there's an OH. En dan gaan jy nou net die res invul. Please remember in a test or exam you must fill in all of your hydrogens. En nou wil ek by jou hoor, which one of these two will have the higher boiling point and why? Watter een gaan 'n hoër kookpunt hê en hoekom? Ja, Shamutai. Hoekom? Yes, because the OH group, the hydroxyl functional group, die hydroxyl functionele groep, is nie afgeskerm nie. So OH is not shielded. Hy is nie afgeskerm nie. Dit wil sê hy het sterker, gaan nou inzoom. Dit wil sê hy het sterker intermolekulêre kragte. Dit wil sê meer energie benodig, bla 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 bla. Dit wil sê hoër kookpunt. Okay, so English, OH is not shielded, stronger intermolecular forces, bigger energy or higher energy needed. That means higher, and English it will be BP for boiling point. Afrikaans copy of kookpunt. Okay. Nou ons gaan later daaraan raak, maar iets wat ja. Iets wat ek wil hê jy moet sien, something that I want you to see, is that these two have the same molecular formula. Dieselfde molekulêre formule. The same structure amper, but the position of the functional group is different. So let's do same but different. Okay? So dit is soos 'n tweeling. It is like a twin. Same, maar verskil. Okay, I'm going to speak about that a bit later. Maar ek sê dit lank vir jou. These two are called isomers. Isomere is die wetenskaplike term vir 'n twin. An isomer is isomer. So these two are called isomers, isomere. So in your head you can think twin, same, but different. So hulle is van dieselfde goed gemaak, they're made up of the same things, but something is different here, the position of the functional group. So we call them positional isomers, posisionele isomere. Positional isomers, van die posisie van die weë ding is op 'n ander plek. Okay. Dan die volgende een wat ons het is die aldehiede, the aldehydes. Okay, so there we can see the aldehyde functional group. You can see it's at the end of the chain. Wat beteken daar R nou weer? What is that R? It's called an alkyl group. Dit wys net vir jou die ketting kan aangaan. The chain can go on. In that place with the R you can put 2 carbons, 3 carbons, 1 million carbons, maak nie saak. Okay, so die ketting kan aangaan daar. What is the name for the functional group for aldehydes? Gaan terug bladsy English page 3, Afrikaans page 4. Formaal groep. Okay. Okay, dan kan jy hoor hier of lees. This is, I want to put this in brackets. Sê 37% oplossing van methanol, anal, anal at the end. Van methanol is formalin, formylgroep, formalin. Where do we find it? As a preservative for biological samples. So dit is wat jy in juffrou Aller se klas kry, daai perkie wat in 'n vloeistof is. Dis daai. Right. Dan, hulle word gevorm deur primêre alkohol wat oksideer. Okay, so you can see there we have propan-1-ol. And then if it oxidizes, you will get propanol. Propanol. Pro, want is it 3? Anal, because it is at the end of the chain. Okay, then ketones, ketone. Ketones, the functional group looks like that. So dit wys net vir jou, this just shows that the C is in the middle and dan gaan die ketting aan. Okay? Please note that you do not have to have one carbon here and then one carbon there. Or 2 here, 2 there. You can have 1 koolstof here and then 1 million there. As long as this is just not at the end. Like at enige plek in die middle wees, it doesn't have to be in the middle symbol. Okay. Then it says there propanone, acetone. Julle almal het al gehoor van acetone, né? Nee? Behalwe dalk Declan. Declan, where do we use acetone? Do you know? Mama will tell you. The nails, when you remove your nails, you dip it in acetone. Okay, acetone word gebruik in napolitoer verwyderaar. Oh my word. Okay. Then we get natural ketones. Jy het al gehoor van kamferolie, camphor oil. En testosteroon, progesteroon. Yes, hormoon. It's almal ketone. Alright, and then there it says they are formed by secondary alcohols that oxidize. So daar wys ek vir jou die sekondêre alcohol and if that one oxidizes, it will form propan-2-one. Kan jy daar agtervoegsel sien? Oon. This is anal, propanol. Propan-one. Okay. Then the last one is the carboxylic acids. Dis is die laaste gedeelte wat ek wil doen vandag. Die carboxylsure, carboxylic acids. Daar sien jy sy funksionele groep. What do we call this functional group again? Ons het vergeet om dit te skryf by die ketone. Wat was dit by die ketone? Sorry. Ek het vergeet van daai karbonylgroep en by die karboksylsure is dit die karboksylgroep. Ek wou nou nog iets gesê het. Ag, jy laat my net by my memo bly. Sorry. Oh, it's okay. Sorry. Please page back again to the aldehydes and the ketones. Okay. Ek wil praat oor hulle intermolekulêre kragte. What type of intermolecular force do you think we find here? London force? Nee, because it's not symmetrical. Daar's 'n ding wat uitsteek. It is dipole. Daar's nie heeltemal, it's not completely, because if that O was bonded to an H, then because of the difference in electronegativity, die verskil in elektronegativiteit, trek hy die elektrone sterker aan, so hy word super negatief en hy is super positief. But we don't have that H there. But the oxygen is still strong enough, so this becomes, very negative as well. So this will form a dipole intermolecular force. Die pool soort intermolekulêre krag. Ja. Nee, maar onthou, dit gaan nie 'n waterstofbinding gaan nie oor die feit dat 'n waterstof naby aan hom kom nie. 'n Waterstofbinding gaan as 'n waterstof gebind is aan stikstof, suurstof of fluor. So as hy waterstof gebind is aan hom en hulle as 'n eenheid kom naby aan iets anders, dan vorm waterstofbinding. Okay. Right, same with a ketone, dieselfde vir 'n ketoon. Because of that, we also have dipole intermolecular forces. Ek dink ek het nou alles gesê wat ek wou sê. Ja. Vir hulle ja, daar is. Okay. So she's asking about the general formula. Thank you for reminding me. Okay, kom ons figure hom uit. Okay, let's figure out the general formula. As ons na hierdie kyk, I'm going to look at this one, the ketone. Then we have CN, let's write C3H, 1, 2, 3, 4, 5, 6, and then 1 oxygen. So it's CNH, 2NO. Kom ons kyk gaan na die boonste ene. Let's look at the top one. Hierdie ene. So this one is the aldehyde. C3H, hoeveel is daar? 1, 2, 3, 4, 5, 6. En O. So it's again CNH2NO. So hulle het dieselfde algemene formule. The same general formulas. If we go to page 2. The aldehydes and the ketones have the same general formula, CnH2nO, CnH2nO. Same general formula, selfde algemene formule. Homeloë reeks is soos dit is al 'n simpel voorbeeld. Jy behoort aan die mens spesies. Ja, kan nie dit sê nie. So homeloë reeks is soos kom ons sê so. Jy behoort aan die wat noem mens iemand wat nie eiers lê nie, wat net soos soogdiere? Hè? Jy behoort aan die soogdiere groep, maar is jy 'n koei? Nee, jy's 'n mens. Okay, so soogdiere is soos as dis seker simpel, soos ja. En dan wat is die naam van die ding wat jou spesifiek anders maak? So die homeloë reeks is soos hulle almal behoort aan die ketone. Okay, so maar jy het 'n groepie, hulle is almal ketone. En wat noem jy daai dingetjie by die ketone? Wat noem jy daai dingetjie wat hom 'n ketoon maak? Simpel verduideliking wat ek gegee het. Ja. Ja. Dan yes, so dan die ketone, wat maak hulle spesifiek? Die karbonielgroep. So hy is homeloë reeks en 'n funksionele groep. So die homeloë reeks het sy eie funksionele groep. Vir so ketone is die hele reeks en die funksionele groep is net daai spesifieke dingetjie, daai dingetjie. Verstaan jy? Okay. Is nog iets wat ek wou sê, maar het ek vergeet. Alright, so the carboxylic acids, die carboxylsure is soos 'n alcohol en 'n aldehyde. Okay, so carboxylic acid is like an alcohol and an aldehyde, or an alcohol and a ketone. So ons het daai twee goeders. Now, what type of intermolecular force do we find here? Waterstofbinding, hydrogen bonding. Okay, now because that happens, omdat dit gebeur en hy eintlik so gaan, Okay, so we have that there. Then, and this here. So we have very negative there. It will attract the H from another carboxylic acid very strongly. And that there will be called a hydrogen bond. Okay? So as gevolg van hierdie ding, due to this thing, having an impact on this whole thing, it will have hydrogen bonding intermolecular forces. And hierdie een specific, this one specifically, will have 1, 2 sites for hydrogen bonding. Okay? So as jy hy het 2 plekke, it has 2 sites where hydrogen bonding can occur. So sê nou maar ek het ethanol en ek het ethanosier. Ethanol and ethanoic acid. Both 2 carbons. One is ethanol and one is ethanoic acid. Which one will have a higher boiling point? Ethanosier, ethanoic acid. Why? Because it has 2 sites for hydrogen bonding and ethanol has 1 site for hydrogen bonding. 2 sites, strong intermolecular forces. Ek weet, maar ek het nou net verduidelik dat hierdie ene, omdat hy so gebuig is, maak dit dat hierdie een baie negatief is. Hierdie een is ook baie negatief, as gevolg van sy enkelpare, 2 enkelpare. Nee, so dis negatief, negatief, en dan trek dit die waterstof van 'n ander carboxylsuur, so na mekaar toe kom, baie sterk aan. En tussen die ander een se waterstof en hierdie een se negatiewe suurstowwe vorm dit, kan dit 'n moontlike waterstofbinding vorm. Okay, dan sê hulle, they use this, or you get it from oxidizing alcohols. Then a slower oxidization process is in the presence of oxygen, waar jy wyn ooplaat en dan vorm dit 'n suur. I explained that at the beginning. Then do we use it in preservatives, ethanoic acid or vinegar, asyn, we use to preserve stuff. Ons noem dit pekel in Engels. We know, you call it, wat is dat woord? Nie pekel nie. Brine. Does it say brine in your thing? Carboxylic acids were in pickles, but we call it, the liquid is called brine. Brine. Okay, ons gebruik dit in disinfectants, and then very, very, very important, we use it in the preparation for esters. So you can see, ek het nie baie gehighlight nie, I did not highlight a lot at all. I highlight preparations of esters, want dit is wat jy moet weet in matriek. Then, there are weak acids, en ons gaan later die jaar, later this year, we will see what is a weak and a strong acid. The weak acids as the ionize only slightly. So hier kan jy sien dat jy carboxylsuur, you have the carboxylic acid, and when it is in the presence of water, as hy nie teenwoordigheid van water is, then it will give away that hydrogen. Hy gaan nou waterstof weggee, and then it forms that ion, an anion, an anion, and it forms this thing. Now, what do we call this thing again? Kan julle onthou? For a lollipop, it has a specific name. And if you can tell me what type of very special bond it has, you can also get a lollipop. Ja? Nee. Dit begin met 'n D vir delicious. Two words. The second word starts with a C for chocolate. You cannot remember? Another clue. What do we call that special bond there? Okay, my lollipop. Yay. It is called a dative covalent bond. A dative covalente binding. And what do we call this one? What's his name? It is called the hydronium ion. Die hydronium ion. Hydronium ion, hydronium ion. Okay. Now, ek gaan nie baie hierso highlight nie because we will discuss this a bit later on in another chapter. Maar wat ek wil hê jy moet sien is carboxylic acid, carboxylsuur, an acid loses the hydrogen to form a hydronium ion. Stel hierso kan jy sien ek jy 'n binding and then it gives away those two hydrogens. Ek gee daai twee waterstowwe weg en dan vorm hy daai twee ione. What do we call it when it gives away two hydrogens instead of one? A diprotic acid. Jy het dit al gedoen. A diprotiseer, diprotic acid, it gives away two. Okay? Daar sien jy ook is 'n carboxylsuur, carboxylic acid, and then it just swap the sodium with the hydrogen. En dis is ook 'n carboxylsuur. En daar is metanoesuur en dan vorm hy kalium metanoaat, dink ek. Anyway, all right. So, what is important for you to know with carboxylic acids? Well, dit het ek al gedoen. You need to know the functional group, the name, the type of intermolecular forces, that we use it as preservatives, whatever, and we use it to make esters. Okay, goed, so ek wil daar stop hierso met hierdie hoofstuk. Wanneer jy nou, wag net 'n oomblik, wanneer jy nou verveeld is by die huis vanmiddag, vanaand ensovoorts, you can for homework try to do on page 31, bladsy 31, that whole page. Jy kan, ek weet is naweek, ek weet julle is moeg, ek weet julle is ander goeie, so I'm not going to make it compulsory, I'm going to do it with you in class, but it will be good practice if you try to just draw these structures. Net teken hierdie strukture vir die hele ding, vraag 1 en vraag 2. Alright.